So this is a video of our 1-2 notes over the distance formula and Pythagorean's theorem. So today's objectives are that you can find the distance between 2 points using a variety of methods. So the distance formula is derived from Pythagorean's theorem. So if you guys remember, Pythagorean's theorem is a squared plus b squared equals c squared, where a and b are two legs of a right triangle and c is the hypotenuse. Remember, the hypotenuse is opposite the right angle, okay? So if we were trying to solve for this length right here, we would square A and square B, and then, like we do here, square A, square B, add them together. And then if we want to get C, don't we have to take the square root of C squared? We do. Okay, so what we do here to get C is we would ultimately take the square root there. That's why we're taking the square root here, okay? So how does that relate to the distance formula? Well, obviously the distance, again, notice the distance over here relates to what? The C here, okay? And our vertical length is y2 minus y1. And we're going to talk about this. You're going to see why these relate to each other, okay? So that was our vertical distance right here, right? And then our horizontal distance is x2 minus x1. That's that right there. So once again, these are just sides, right? So this would be like our B right here, and this would be like our A, and this would be like our C. Y'all see it? So that's why they relate to each other that way. So none of this is on your paper, so you're going to need to write it down. So pause the video here, go ahead and write all this down, and then we're going to use it in just a minute. All right, so now it says Pythagorean theorem versus the distance formula. So it says find the distance between point A, negative 1, 5. So negative 1 is 1 left and 5 up. So that's our A. And then we've got B at 3, 1. So 3 to the right, 1 up. That's B. Okay, so now I'm going to teach you guys how to use Pythagorean's theorem. And then we're also going to use the distance formula and see which one you guys like the best. Okay, so we're going to go down 1, 2, 3, 4. Do y'all see that? And then we're going to go over here to B. And so you notice what we just made. We made a right angle, didn't we? So then we're going to find this length right here, AB. That's what we're looking for, okay? So we created a right angle. That means we can use Pythagorean's theorem, right? So if we look at from the negative 1 to the 3, then this length down here is also 4, isn't it? So that means we're going to make this one, I'm going to make this one equal to our A, and I'm going to make this one equal to our B. That means this would be our C. So what are we going to do here? We're going to do 4 squared plus 4 squared, and that's going to be equal to our C squared, right? So that's going to be 16 plus 16, that equals C squared. So that's 32 equals C squared. Now what do we have to do to get rid of the square? We have to take the square root. Now, yesterday when we talked about this in our warm-up, if you remember, we always put a plus or minus in front of anything we took a square root. So now we could write this answer a couple different ways, but most of the time when for this particular lesson, because we're going to be finding the perimeter, I just want you guys to go ahead and take the square root of 32. Okay, and when we take the square root of 32, the square root of 32 is approximately, because we're going to have to round it, 5.66, okay? Now, we could write it in simplest radical form. We'll talk about that later because that's not really relevant for this particular lesson, okay? So now distance formula would mean we're going to take those 2 points, okay? So that means we're going to label these. Our A is negative 1, 5, so that's going to be our x1, y1. And our B, 3, 1, is going to be our x2, y2, okay? So in our distance formula, again, actually, I'm just going to put AB there because that's what we're really looking for, the length of AB. AB is equal to, so we're going to take our x2, which is 3, minus a minus 1. We're going to square that, plus our y2, which is 1 minus 5, and we're going to square that. So you can already see minus a minus, that's a plus, right, y'all? Right there? See that? Okay, so this is going to be 4 squared plus negative 4 squared. Again, we're still taking the square root of that, so that's going to be 16 plus 16, which was what, y'all? Square root of 32. So it is the same answer, y'all. AB is approximately 5.66. So how can we compare the two methods? we had to square both sides, right? So remember, this is a side length and this is a side length, right? One of them was horizontal, one of them was vertical. And then we had to take square root of it. So that's how they compare to each other, okay? It's really the same process. So we square the both, we find the length of the sides. That's what this is right here. Y'all see this? This is the length of a side. This is the length of a side. And then we take the square root of it to find the length of the hypotenuse, okay? You can write that out if you want to. All right, so now we're going to use this. It says find the length of each side, then calculate the perimeter. So down here for AC, I'm going to start with AC down here. Y'all see this AC right here? I'm going to start with that because I can count it. 1, 2, 3, 4, 5, 6. So AC is equal to 6. Now we're going to use Pythagorean's theorem to solve for the other two side lengths. Okay, so I'm going to go up here and I'm going to, let me actually do a different color. I'm going to go up here and I'm going to go across there and I'm creating a right triangle. Y'all see that right triangle? So let's count again. 1, 2, 3, 4, 5. So this is 5. This one's 1, 2, 3, 4. Okay, so how are we going to solve for AB? We're going to do AB squared is equal to what? 5 squared plus 4 squared. So that's going to be 25 plus 16. So AB squared is equal to, what is that going to be? 41? I think so, right? Yeah. 41, square root of 41 is equal to AB squared. We're taking the square root of this so we can get AB, right? So AB is equal to, let me find this, y'all. Square root of 41 is 6.4, okay? All right, now we're going to find BC, doing a similar thing with it. So here again, we're going to the right and down, created a right angle there. This is 2. 1, 2, 3, 4, 5. This is 5, okay? So now we're going to find BC. So BC squared is going to be equal to 2 squared plus 5 squared. So that's 4 plus 25. So that's 29. So BC squared, again, is equal to 29. So what are we going to do to both sides again? Take square root, right? Take square root here, take square root here. So that's approximately, I got 5.39. Okay, so now what do we have to do to find the perimeter? We have to add all three of those sides together, right? So we want to do AC plus AB plus our BC, right? Okay, so what is that going to be? That's going to be 6 plus 6.4 plus 5.39. So that's 12.4 plus 5.39. So that would be what? 12 plus 5 is 17. And that's going to be 0.79. 17.79 is the length of our, the perimeter. That's our perimeter right there, 17.79. Sorry. All right, so go ahead and do this one and work through it like we just did, okay? So this one, this was labeled on y'all's paper, M, N, O, and P. So I would do M, N, and O, P first if it was me, or P, O. 1, 2, 3, 4, M, N, P, O, 1, 2. So now, can you guys tell that PM or MP and NO are going to be the same? Can everybody see that? So this is 3 tall, 1 wide, right? So is this 3 tall, 1 wide. Y'all see that? Those hypotenuses are going to be congruent, aren't they? So I could say MP is equal to NO, which is equal to 3 squared plus 1 squared. So that's going to be, and these are actually going to be, remember, we're going to take square root of whatever that is. So that's 9 plus 1 square root of 10, which is approximately what? 3.16, right? So remember, there's two of those, right? So we're going to add 4 plus 2 plus 3.16 plus 3.16. Agreed? So that's going to be 12.32. Everybody got it? Okay. All right, now it says find the distance between A, B. So we're going to use the distance formula for this one. Sometimes we're going to have to use the distance formula. Okay, so with AB, again, remember, we're going to label this x1, y1, x2, y2. Okay, so we're going to do our x's first, and then we're going to do our y's. Okay, so I'm going to do x2, 4 minus a minus 1, and then I'm going to do negative 19 minus 7. So remember, minus a minus is a plus right here, right? So what is that number? That's 5 squared, right? Plus negative 26 squared. So that's going to be 25. And 26 squared, negative 26 squared, is going to be plus 5. Sorry, 676. 676. Still going to take the square root of that. That's going to be 701. Now it says, write it in simplest radical form. Well, that can't be reduced, y'all. I tried everything last night. And yeah, so this is 26.48. So it says round to the nearest hundredth, okay? Can't be simplified because there are no perfect squares that are factors of 701. Then it says find the distance between these points. So again, what are we doing? x1, y1, x2, y2. Here's our formula, and it's on the formula sheet, y'all. So our distance here is going to be x2, 1 minus a minus 3 squared plus negative 2 minus a minus 6 squared, right? Got it? We've got those minus and minuses again. So we got a plus there. We got a plus there. So 1 plus 3 is 4. And negative 2 plus 6 is also 4. Wow, this one looks a lot like something we did earlier. Right? So that's going to be the square root of 32, which is approximately 5.66, right? So again, most of these that we're going to use in this unit, we're doing this to find perimeter, okay? Or we're going to find area ultimately as well, okay? So do this last one. Come back to me when you're done. So the distance again, I'm going to do 10 minus a minus 5 plus 10 minus 5. So that's going to be minus is plus, right? Got a plus right there. So that's going to be 15 squared plus 5 squared. That's 225 plus 25. So that's the square root of 250, which again is approximately 15.81. Okay?